on surface. This is a surface. Over the surface, a spherical ball is kept. And this is the source. This is the source. The radius of this sphere is given as capital R, and the distance between the center and the source is given as 2R. Okay, solve it now. What will be the area of patch on the surface? The question is similar to the question we did yesterday. Yes, one more minute. Yes, Hemant. Hello, am I audible? Are you there in class?
You're audible. Hello, sir. You're audible, sir.
Yes. I am saying that what is the answer?
Sir, I'm
What
not.
what are you trying?
Sir, I'm not getting. Sir.
See, nothing. It is the same question as we did yesterday. You should have seen this question.
Yes, sir.
Okay. What we are doing, we were projecting the rays of light from the source and then we opted out a triangle. This upper triangle we opted out. Okay. Similarly, do this here. Draw the lines from the source. Draw the lines from the source like this. These are the rays of light. Okay. Hmm. So now we projected this line like this, and because of this, we would be seeing a shadow. We would be seeing a shadow of the sphere like this. This is the shadow of the sphere. Okay. We need to calculate the area. For calculating the area, first we need to find out what is the radius. Okay. Let us take this radius as x. To calculate the radius, drop a perpendicular from the vertex to the center of this larger sphere. Now see, now clearly we have two triangles. What triangles we are having? Now, if you join this line, what will happen? This line will be perpendicular, is it not? To the tangent? Yes, it will be perpendicular. This distance is 2r. This is a perpendicular, okay? This distance is x. And this green distance is r, is it not? This green distance is r. This angle is theta. Now we have two triangles. What two triangles we are having? We are having two triangles like this. This is our first triangle. This is r. This is 2r. And this is our hypotenuse. Angle here is theta. Similarly, we have one larger triangle. We have one larger triangle. This triangle we are having here. Okay. Now let us redraw that triangle. Second triangle is this. Second triangle is this. What is this total length? Can you tell me? This total length is 3r, is it not? Yes, Hemant.
Yes, sir. It's clear. Yes, sir.
This total
Yes, sir.
length,
It's clear.
total length is 3r. This perpendicular radius is x, and that is the slant height. What is this angle? Can you tell me? This angle is still theta, is
Yes,
it
sir.
not?
Yes, sir. It's on.
Because the angle is same, two angles are same. This is right angle, this is theta. It means this angle will be alpha in both the triangles. All three angles will be same. Why? Because two angles are equal. Then the third angle ought to be equal. It means both the triangles are similar. Both the triangles are similar, is it
Swimming.
not?
Yes, sir. It's.
Okay, both the triangles are similar. Now, from here also you can calculate x means r upon 2r. Just wait a minute. theta is this, theta is that is r. Now this is opposite to theta, this is the angle, and opposite to theta, this is the angle. Okay, no, here this is not 2r, this is not 2r, I'm sorry, this is not 2r, this is 2r.
Oh,
This is the hypotenuse. Hypotenuse is 2r, is it not?
yes, sir.
Yes, the hypotenuse is 2r. So this is what? This is 4r square minus r square under root. Okay, getting it or not?
Sir, I'm getting sorry, sir.
4r square minus r square. Why? Square of hypotenuse minus square of side will give us the third side. A square plus b square equal to c square. Okay, this is a, this is b, and this is c. So c square minus b square will give us a square. C square is 4r square minus r square will give us this side. Now we can apply each and everything. What is that each and everything? That is nothing but property of similar triangles. In both the triangles, since both the triangles are similar, therefore what will happen? R upon x will be equal to under root 4r square minus r square is what? 3r square upon 3r. So what will be x? R upon x is equals to root 3 into r upon 3r. R and r will cancel out. X will be what? X will be 3r upon root 3, or we can write root 3r. This is the answer. X is root 3r. Therefore, what will be the area? Therefore, area will be equal to, yes, what will be the area? Area will be equal to pi r square. Now,
Pi
what is
into
the
root
radius here? Radius is root 3r. So,
3. Yes,
pi
sir.
into root
Root
3r
3
whole square. Answer is 3 pi r
pi.
square. Answer is 3 pi r
3 pi
square.
r.
Got it
Yes.
now?
Yes, sir, got it, sir.
Got it now? Take the solution down.
Sir, copy it.
Done. Now, let us write laws of reflection. From now onwards, we are starting reflection. Reflection of light. Now, what do you mean by reflection of light? What is reflection of light? Reflection of light is nothing but bouncing back of the light rays after striking a smooth surface, a smooth or any kind of surface. Light is always reflecting. Anywhere light is incident, after striking the surface, it will be reflected back, that's for sure. Okay. But in some cases, we can see even our face over the surface. But in some cases, we are not able to do so. Why? Because slowly the surface becomes rough. Like whenever you buy utensils and when the utensil is brand new, you are able to see your face on the shining surface of that utensil. But after that utensil is used up for several days, then what happens? Its luster, its shining, it fades away. And now you are not able to see your face or anything on the surface of the utensil. Why? Because now the surface has become rough. Metal is same, but its surface is not polished. It is not smooth as before. It is rough surface now. So actually reflection is nothing but, you already know this, bouncing back of light rays. It is bouncing back. Now you already know reflection is of two types, is it not? Reflection is of two types, irregular and regular. What is irregular reflection? Do you remember anything?
If the reflection occurs at irregular surface,
Irregular surface, it means the surface is rough. And regular reflection, when the
the
reflection is
surface
from, yeah, when the surface is very
smooth surface.
fine. Okay. Now reflection is happening, whenever reflection is happening through any surface, it follows some laws. What are the laws of reflection? You might be knowing them already. First law of reflection is angle of incidence. Angle of incidence is equal to the angle of reflection, to the angle of reflection. Okay, it means what? Angle I equals to angle R. Second law of reflection is what? Second law of reflection is incident ray, the reflected ray, and the normal at the point of incidence all lie in same plane. The incident ray, the reflected ray, and the normal at the point of incidence all lie in the same plane. All lie in the same plane. Okay. Now, this plane on which all these three things are lying. What three things I'm speaking about here? These three things are incident ray, reflected ray, and the normal at the point of incidence. This is a mirror. Okay, incident ray is this, reflected ray is this. This is incident ray, this is reflected ray, and this is normal at the point of incidence. This point O is the point of incidence. This is angle of incidence, angle I. This is angle of reflection, angle R. So it's states first law is angle I is equals to angle R. And second law is that all these things, all these three things, mirror, normal, and this incident and reflected ray, they all are lying on the same plane, which is called as plane of incidence or plane of reflection. This condition, which we are writing here, it can be expressed mathematically. This condition, write down, this condition can be expressed mathematically as dot product, see, r vector dot I cross n will be equal to n vector dot I vector cross r vector will be equal to I vector dot n cross r equal to 0. Okay, these three are the vectors where I, n, and r, all these are what? These are vectors. I, n, and r are vectors of any magnitude along incident ray, comma, the normal, and the reflected ray respectively. Take it down. Yes, taken down.
Copy it, sir.
Done?
Sir, copy it, sir.
Fine, fine.
Yes.
Next. Now here one thing
Sir,
is
voice,
important. We have seen that this is the incident ray. Hello.
sir, voice
Yeah, is
is
it clear
breaking.
now?
Sir, sir, I will rejoin, sir, 1 minute, sir.
Uh,
Hello, sir.
yes, is my voice clear now?
Yes, sir, now it's clear, sir.
Okay,
Now
fine.
it is clear, sir,
So
voice.
here, fine, fine, fine. So here, what is happening? Angle of incidence is equal to angle of reflection, that we know. Now, what is this angle? This angle and this angle, they are also equal, because this angle I and angle R, they both are equal to each other. That's why this angle is also, these angles are also equal to each other. These angles are called as glance angle of incidence, and glance angle of reflection. Glance angle of incidence and glance angle of reflection.
Reflection.
Okay. Now here some special cases are there. What are those special cases? Yes, what are those special cases? Special cases are of normal incidence. First is normal incidence. Normal incidence. In normal incidence, what is happening? Light is incident normally. Light is incident normally. It means what? Angle of incidence is equal to angle of reflection equal to 0. Now, in this case, light will be falling like this. Okay. So whenever light is falling like this, there is both of them are 0. This is called normal incidence, and second is grazing incidence. Grazing incidence. What is grazing incidence? Grazing incidence is when the light ray is just touching the mirror and is incident parallelly like this. Light is incident parallel to the mirror. This is called grazing incidence. Grazing incidence. Light grazes, or grazes means what? Tangentially incident on the surface. Fine. These two are the special terms in which one is named as normal incidence and another is called grazing incidence. Okay. Now next we come. Let us come upon object, definition of object and image. Yes. Now tell me, what is an object? What do you understand by an object? Yes, Hemant.
So anything, so I mean we can say like, so anything that
Anything?
is we are seeing is called an object.
No. No, no, no. In physics, object is not a thing. And especially in optics, it is not a thing. In optics, see, what is an object? An object is a thing from where the incident light rays are coming, is it not? Can we say that? Like if I am seeing a, like this, a pen I am seeing, this pen I am seeing. Okay. Now this pen is an object. When I am able to see this. When I will be able to see this? When the light rays are incident on my eyes originating from this pen, means light rays are going out of the surface of this pen and reaching to my eyes. It means for my eyes, these light rays are incident light rays, is it not? And all
Yes.
these incident light rays are meeting at this single object or single point. It means I can define the object as point of intersection of all the incident rays. Point of intersection of all the incident rays. This is defined as an object in optics. It is defined as a point of intersection as a point of intersection of incident rays. Point of intersection of incident rays. Got it now? Taken down?
Yes, sir, copied, sir.
Now, see, this is an object. This object can be a point object as well as an extended object. Object is of two types: point object and extended object. Point object and extended object. What is point object? Point object is that point from which all the incident rays are actually emerging. This is called a point object. Or we can say, or towards which the incident rays appear to converge. This is called a virtual object. For point object, write down: a point object is that point from which the incident rays actually diverge, from which the incident rays actually diverge. This is called a real object. Or towards which the incident rays appear to converge. This is called as virtual object. Okay, these two objects can be visualized like this. This is a real object. Rays from a real object are going like this. This is a real point object. Okay. This is a real point object. Of this real point object, a virtual image will be formed. This is virtual image which is formed of this real point object. Virtual image. Okay. Now this point is a virtual object. When this point is a virtual object, when yes, this is a virtual point object. And this is what? This is real image. This is real image. Here what is happening? Diverging rays are incident, and here what is happening? Converging rays are incident. Here converging rays are incident. And here is what? Here diverging rays are incident. Got it now? This is
Sir,
the
got
meaning
it.
of virtual object and real object. So this was all about the object. Extended object can be considered to be made up of several point objects. Extended object is can be considered as a collection of several point objects. So all these things which we have learned now, we are not going to describe them again for extended objects because it is nothing but collection of several point objects. Okay, taken down this thing about object.
Yes, sir, copy,
Hello,
sir.
yes, tell me.
Sir, copy, sir. Sir.
So next, fine. So next is image. What is an image now? An image is what? Yes. Now you have seen the object. Now you can give some idea about image. What is an image?
It's a point of intersection of rays, you can say. So light is originating from object is what.
Hello. Yeah, am I audible? Fine. See, see, this image is nothing but point of intersection of what? Of reflected rays. Object is point of intersection of incident rays. Image is what? Point of intersection of reflected rays. So image is what? Point of intersection of reflected rays. Reflected rays in case of reflection or refracted rays in case of refraction. In case of refraction. Now, what is the real image? Real image is formed when in reality the rays of light are actually intersecting at a particular point. A real image is formed when when the light rays when the light rays converges at a point. This is a real image. And what will be a virtual image? A virtual image will be formed when the light rays appear to come from a point. They are not coming from a point in reality, but they appear to come from a point. So a virtual image is formed when light rays appear to come from a point. When light rays appear to come from a point. Now, it is not necessary that we are taking object in front of the mirror. Okay. See like this. If this is the mirror, F is a mirror. Okay. And light rays are coming like this. This is a real object here. Okay. Its image will be formed here. This image will be virtual. This is virtual image. Okay. Now here this object is not kept in front of the mirror. This is virtual image, and when it will be a real image, it will be real image in this case. In this case, this is the real image. Okay, and this is what? This is virtual image. So same diagram is there. Fine. Take it down. Take it down fast. Yes, done. Hemant.
Sir, sir, copied, sir.
Hello. Copy.
Sir, copied, sir.
Fine. Fine. Now let us come upon plane mirror. What is a plane mirror? Plane mirror is actually a highly polished plane surface. It need not to be a glass. Any surface which is highly polished can act as a mirror. Okay. A highly polished metal surface, like if you have ever been to Kerala, you might have heard about one Arnamul Kannadi. Kannadi is mirror for Kannadi is a word for mirror in Malayalam. Now That Arnamul Kannadi is actually a piece of metal. It is a piece of metallic alloy which uses silver, tin, little bit of gold, a little bit of copper. What is the ratio? That ratio is actually possessed by a particular family, as it was. It is said that it was given by uh, God, the presiding deity of that Arnamul town, to that family. So, thing is that that mirror is made up of metal, of silver, and all these alloys. And when all these alloys are mixed in that particular ratio, they just give a very shiny luster, very shiny luster. And that that piece of metal, it can reflect 100% of light incident on it. No light is refracted like in a glass mirror. In a glass mirror, a part of light is also refracted back in the medium. So whatever light we are seeing, whatever image we are seeing, that image is little bit dim. But in that case, in the case of that Arnamul Kannadi, it is not so. Only primary reflection is there. From primary reflection, an image is forming, and that image is super bright. So again, it is a highly polished plane surface that regularly reflects nearly all light falling on it. Write down a highly polished, a highly polished plane surface that regularly reflects nearly all light falling on it is termed is termed as a plane mirror. Okay. Now, characteristics of the image formed by a plane mirror, or you can say properties of plane mirror. These properties of plane mirror, they are very important from us, and from this point onward, we will continue in our next class. Okay. Hello.
Sir, okay. Okay, Suresh.
Fine. So our next class will be Monday, and Monday onwards we'll be starting class 11th also. So from which chapter you want to start with class 11?
Uh, sir, from starting we can, from
Hello. Yeah,
starting
am
we
I
can,
audible, Hemant?
sir, from starting we can start, sir. From starting we
Okay,
can start.
in class 11th, starting is from basic mathematics.
Sir, means
So
kinematics.
you want it
Kinematics.
from basic mathematics or units and dimensions?
Sir, kinematics we can start.
Kinematics. Okay, then fine. So yeah, okay. So from kinematics we will start. I will recommend you to revise all the things because I think the classes are for advanced, is it not?
Yes, sir, from up to advanced level ones.
Hmm. Okay, fine then. So I will share the material with you. I have
Yes,
advanced material with me. I will share that material with you. And for advanced classes, please keep one thing in mind. You have to try a lot of questions.
yes, sir.
Questions will be more. We will be focusing more on the questions and less on the theory part, because theory is already given to you, I think, in class 11. Okay. So just revise the concept of kinematics, and we will see the questions in our next class. We will start from 6 p.m. From 7 p.m. onwards, we will start our this 12th class, and we'll continue from the properties of plane mirror. Okay.
Yes, sir. Okay, sir.
So you have 2 days with you to revise kinematics. Okay, because right from the starting we will be taking advanced questions. Okay.
Yes, sir. Okay, sir.
Okay then. Thank you. That's all for today.
So thank you so much.
Bye bye.